Additive manufacturing. Myself, Dr. Suman Das, Professor, Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. So in this video, we will discuss the solid sheet system. Now, the solid sheet system. One of the earliest additive manufacturing technologies was the laminated object manufacturing, that is called LOM system from USA. Now, this technology used a laser to cut out profiles from sheet paper. That means laser is used to cut the sheet paper supplied from a continuous roll. That means that sheet paper is supplied from a roller and it is continuous process which formed by layers of the final part. The layers were bonded together using a heat activated resin. That means an heat activated resin is used that bond the material, that sheet material that was coated on one surface of the paper. So that bonding material is coated the one side. Once all the layers were bonded together, the result was very like a wooden block. So that will be looks like a wooden block. A hatch pattern cut into the excess material allowed the user to separate away waste material and reveal the part. That means waste material will be removed. So if you see the diagram, so this is the XY plotter and this is the excess material. Excess material is that is rolled with the help of a roller, and this is the supply material. So this is the, and this one the build platform, and finally the one layer is on the another layer, and the one side of the layer is there is a bonding material. Cubic technologies, laminated object manufacturing, that is called LOM, cubic technologies. So solid sheet system. Now we will explain. So what is the principle? The parts are built layer by laminated each layer of paper or other sheet form materials, and the contour of the part on that layer is cut by a carbon dioxide laser. That means carbon dioxide laser is used to cut the sheet material. Each layer of the building process contains the cross section of one or many parts. The next layer is then laminated and built directly on top of the laser cut layer. So that is very simple and easy to understand. So if you see the diagram, that is the diagram, that is figure 1, that is the slice cutting with the help of laser, and that one by one stacking, that will be from diagram 2. It is very clear that one slice is on the another slice, and there is a lamination, there is a slightly pressurized with the help of external pressure, and conventional binder removal and sintering. So this is the step number 4, and this is the finished component. So this is the final product. So the final product will be looks like a wooden block. Now the Z control is activated by the elevation platform which lowered when each layer is completed. So this is the Z control, so that can be lowered and gradually from this lowering from top to bottom, and the next layer is then laminated and ready for cutting. So this is the raw material pulled, and when it is passing through this, and this is the laser that will cut the material, and that comes down, and another layer will passing through this, and this is the laminated roll. So this is with the help of the roller, so that will be paste. No additional support structure are necessary as the material which are cross-hatched for the laser removal support. So this is another diagram. So the very simple diagram. So this is the heated roller, this is the laser beam, laser is coming, and this is the foil supply, and after cutting, so that will be excess cool excess material will be rolled with the help of this roller, and this is the heated roller that will paste that laminated material. In this way the entire product will be produced, and this is the platform that will gradually comes down. Now process. The process consists of three phases: pre-processing, this is building, and another one is post-processing. Now pre-processing. So generating an image from a CAD derived STL file of the part to be manufactured, shortening input data and creating secondary data structure. Next one is the LOM system software. The LOM system software calculates and controls the slicing function. Orienting and merging the part on the LOM system are done manually. And LOM slice provides a menu-driven interface to perform the transformation, that is translation, slice scaling, and mirroring, as well as merges. Now the building. Number one, laminated object manufacturing slice creates a cross section of the 3D model measuring the exact height of the model and slice the horizontal plane accordingly. The software and the image crosset which defines the outer perimeter and convert this excess material into the support structure. Point number 3. The computer generated pieces calculation which guide the focused laser beam to cut the cross-sectional outline, the cross hatches, and the model perimeter. The laser beam cuts the thickness of the layer of the material at a time. So if you see the diagram, so this is the cutting and this is the new layer. So this is the bonding of that, and finally this is the cutting. So this is the continuous process. After the perimeter is bond, the model's boundary is freed from the remaining sheet. The platform with the stack of the previously formed layers skinned and new section of the material advances. The platform ascent and the heated roller laminates the material to the stack with a single reciprocal motion, thereby bonding into the previous layer. The vertical encoder measures the height of the stack and relays the new height to LOM slice. This sequence continue until all the layers are built. So that will be continued until the entire layer will be built. So the same diagram, this is the new layer and this is the bonding with the help of that heated roller is passing through this, and after cutting, so this will be looks like this. So if you see the diagram, so this is the excess material will be pulled with the help of this roller, and this is the supply roller. The material will be supplied, and this is the heated roller, and this platform will be gradually comes down. So this is the laser system, carbon dioxide laser, that will cut as per requirement. So the same diagram in the different mode. So that is the mirror, that is the deflected mirror, and this is the layer contour, and this is the platform, and this is the heated roller. Heated roller will pass through this, and this is the excess roller. This is the excess material will be rolled with the help of the this roller, that is the take up roller, and this is the supply of the material, sheet material that will be supplied. Okay. Now post processing. So post processing includes separating the part from the support material and finishing it. So that will be post processing, that will remove the excess material from the entire product. Separation sequence is as follows. Number one, the metal platform home to the newly created part is removed from the long machines. A hammerer and the putty knife are, are all that is required to separate the long block from the platform. So these are required. Number three, the surrounding wall frame is lifted off the block to expose the cross-hatched pieces of the excess material. And number four, the cross-hatched pieces may then be separated from the part using wood carving tools. So if you see the diagram, so this is the diagram A. So the laminated stack is removed from the machine's elevator plate. So that is removing. And finally, the surrounding wall is lifted off object to expose cubes of excess material. So excess material is removing. So that is called post processing. Similarly, this is the another picture. So the cubes are easily separated from the object surface, and this is the diagram. The object surface can then be sanded, polished, or painted as desired. So this is the post processing. Similarly, now this is the application part. So visualization, what is the application of the post processing? So long parts often themselves well for the design verification and performance evaluation. So this is the manufacturing is, and this is the rapid tooling. The process is also used to prepare parts of a model from CAD data in less time and at a lower cost compared to traditional manufacturing methods. Thank you very much.